The world arms market during the Cold War was divided into two camps, Western style and Soviet style. Western equipment was known for its precision craftsmanship and versatility, but at a high price, while Soviet weapons were known for their economy, practicality and systematization. There is a deeper military philosophy behind this difference. There is a generational gap between the monkey versions of Soviet equipment exported to the outside world and their own models, and more critically, Soviet weapons need to be based on a complete combat system in order to be truly effective. In the field of fighter jets, this systematic thinking has evolved a unique spectrum of equipment from the MiG-21, which focuses on air combat, to the MiG-25, which is used for strategic interception. Each model is like a proprietary part of a precision instrument, which together builds the Great Wall of the Air, which makes NATO tremble with fear. In 1957, the United States Blackbird reconnaissance aircraft prototype, a 12 first flight success, its Mach 3.35 speed and 25,900 meters of lift, instantly shredded the Soviet Union's hard-earned air defense network. What shocked the Kremlin even more was that North American aviation was secretly developing the XB-70 Valkyrie strategic bomber, a nuclear strike platform that not only had Mach 3 capability, but could also drop 14 nuclear bombs at 21,000 meters. At the time, the fastest Soviet air defense missiles could barely intercept Mach 2 targets, and conventional interceptors were like static targets in front of the Valkyrie. In the face of the technological gap, Soviet engineers showed amazing reverse thinking. While the West was obsessed with titanium alloys, Rostislav Belyakov, the chief engineer of the Mikoyan Design Bureau, had the courage of his convictions to build the main body of the fuselage from 8mm nickel steel. This seemingly bulky solution not only broke through the high-temperature bottleneck, but also reduced the manufacturing cost to 1/5 of its Western counterpart. Together with the Ir-15-300 engine developed by the Tumansky Design Bureau, a violent machine with a 5-stage pressurized gas engine and a pressurized combustion chamber for injecting liquid oxygen, with a single thrust of 110 kN, the twin-engine configuration allowed the MiG-25 to achieve a high-thrust configuration, gave the MiG-25 a thrust-to-weight ratio exceeding 0.41, allowing vertical climb even with a full fuel load. On the 10th of March 1961, the prototype Ya-155 broke Mach 2 on its maiden flight at the Zhukovsky Test Flight Center. 4 years later, during special tests, test pilot Alexander Fedotov flew the improved version to 37,650 meters, setting an unbroken record for the lift of a manned combat aircraft. And at the 1967 Moscow Aviation Festival, the sonic boom caused by 3 MiG-25s skimming the observatory not only shattered the windows of the neighboring buildings, but also cast a huge shadow over Western observers. The fastest NATO F-104 at the time had a terminal speed of Mach 2.2. In October 1971, over the Sinai Peninsula, 4 Egyptian Air Force MiG-25 or reconnaissance planes flew like nobody's business. Israel's emergency liftoff of the F-4E Ghost fighters, even if the opening of the accelerated combustion can only see the target to Mach 2.8 speed disappeared on the radar screen. More shocking is that when the Israeli army launched AIM-9D Rattlesnake missiles to implement the interception, MiG-25 actually threw a sudden acceleration to get rid of the lock. This 2.5 Mach air-to-air missiles cannot catch up with manned warplanes, a complete reversal of the Western theory of air combat. This encounter triggered the NATO MiG-25 panic. U.S. Air Force intelligence incorrectly assumed that the aircraft was equipped with a revolutionary pulse Doppler radar and a titanium alloy fuselage, and even imagined black technology such as adjustable air intakes. In fact, Soviet engineers solved the systematic problems with the wisdom of the clay method of steelmaking. Its Smirka radar, although using bulky vacuum tube elements, has a peak power of 600 kilowatts, together with a giant parabolic antenna with a diameter of 1 meter, and a detection range of more than 100 kilometers to the bomber target. Stainless steel fuselage, although the weight increase of 30%, in exchange for the whole structure of the aircraft, can withstand a sustained overload of 5.5 G. The amazing strength of the structure of the plane is also a result. The stainless steel fuselage is 30% heavier, but the whole structure can withstand 5.5 G continuous overload. This design philosophy was best demonstrated in the Bekaa Valley Air War, where in June 1982 the Syrian Air Force's MiG-25 PD fleet was able to conduct over-the-horizon intercepts in an electronically jammed environment, relying on the ground-based Sky-SV radar network and automated command system. Despite the unfavorable battle-loss ratio, there is a record of MiG-25 successfully breaking through the F-15 escort circle and injuring an Israeli E-2C early warning aircraft with an A-40 missile. This systematic combat capability is the essence of Soviet air defense thinking. Individual platforms may not be perfect, but through the data chain will interceptors, radar stations, air defense missile positions into an organic whole, you can form a suffocating opponent's air defense dome. At Hakodate Airport, Hokkaido, on the 6th of September 1976, the MiG-25P piloted by Captain Belenko not only brought with it the wreckage of the fuselage, but also unveiled the mysteries of the Soviet aviation industry. The National Aerospace Intelligence Center's dismantling report showed that the electronic equipment of this doomsday fighter remained at the level of the 1950s. The autopilot needed to preset the mechanical cam trajectory, and the radar display even needed to manually calculate the parameters of interception. But it is this backwardness has created a unique advantage, 80% of the aircraft's stainless steel structure, so that it has amazing battlefield survivability. In the 1981 Iran-Iraq War, had the organism by the F-14 Tomcat hit 23 rounds of 20mm shells, are still safe to return to the flight. In-depth analysis reveals the pragmatic wisdom of the Soviet engineers, although their 15 engine life of only 150 hours, but its modular design allows the front-line troops to complete the replacement within 45 minutes. The hydraulic system uses high-temperature resistant AMG6 alloy piping, can be in 400 degrees Celsius environment normal work. Specially designed deceleration parachute pods are located in the root of the drogue tail, even if the fuselage is seriously damaged, to ensure that the landing safety. These details highlight the Soviet design philosophy of built for war, not to pursue the glamour of laboratory parameters, but to ensure that in a nuclear war environment, can still maintain the attendance rate. The legend of the MiG-25 did not die with the end of the Cold War, as Iraqi Air Force Colonel Zuhair Daoud piloted a MiG-25 PDS in the 1991 Gulf War, successfully attacking a U.S. air fleet under the cover of cloud cover, and shooting down an F-18C Hornet with an R-40TD missile, creating the last confirmed battlefield success for the type. More profoundly, its design experience led directly to the MiG-31, an interceptor equipped with a phased array radar and R-33 long-range missiles, which is still the backbone of Russia's Arctic air defense. From the perspective of engineering philosophy, the MiG-25's violent aesthetics are a profound revelation. When there's a generational gap in materials science, asymmetric advantage can still be achieved through system integration and tactical innovation. The ultimate criterion for weapon effectiveness is not technical parameters, but the suitability of the combat system. This kind of thinking still shines in the present day, just as Russia has been able to maintain the reliability of its strategic equipment through a hybrid architecture of analog circuits and digital systems despite the backwardness of microelectronics technology. The story of the MiG-25 reminds us that the essence of military innovation is the art of finding optimal solutions within realistic constraints. When the MiG-25 stands quietly in the museum, the stainless steel skin can still see the thermal oxidation marks left by the high-speed flight. These traces are not only a witness to the Cold War military-industrial competition, but also a medal for human breakthroughs in technology, in the era when titanium alloys and integrated circuits ruled the aviation world. The Soviet engineers used 8mm steel plates and vacuum tube components to write an air legend belonging to the Steel Phoenix.